In 1990, Honda did something that no one expected. A company known for economical civics and reliable Accords suddenly dropped a bombshell that would redefine what it meant to be a supercar. The NSX wasn't just another Japanese sports car, it was a revolution wrapped in aluminum and powered by an engine that would make Ferrari engineers lose sleep. At the heart of this revolution sat two engines that would become legends in their own right: the C30A and its bigger brother, the C32B. These weren't just engines, they were masterpieces of engineering that proved you could have exotic car performance without sacrificing the reliability Honda was famous for. This is the story of how Honda created the perfect naturally aspirated V6 engines and why they're still considered among the greatest power plants ever built.
The late 1980s were a fascinating time in the automotive world. Ferrari dominated the exotic car scene with their temperamental but intoxicating V8s and V12s. Porsche had their air-cooled flat sixes that were as much about character as they were about performance. And then there was Honda, making some of the most reliable cars on the planet, but nothing that could make your heart skip a beat. That all changed when Soichiro Honda himself made a declaration that would alter the company's trajectory forever. He wanted Honda to build a car that could rival Ferrari, but with typical Honda reliability. It sounds almost contradictory, doesn't it? How do you create something that's exotic and exciting, yet dependable enough for daily use? The project was given the internal code name HPX, Honda Pininfarina Experimental. Yes, the same Pininfarina that had been styling Ferraris for decades was now working with Honda. But the real magic wasn't going to happen in the design studio. It was going to happen in Honda's engine development labs. Honda's engineers faced a monumental challenge. They needed to create an engine that could produce exotic car levels of power and performance, rev to stratospheric RPMs like a Formula One engine, maintain Honda's legendary reliability, be refined enough for daily driving, and do it all naturally aspirated because turbocharging was seen as cheating by the purists. The team was led by some of Honda's most brilliant engineers working out of their Tochigi Research and Development Center. They had already proven their engineering prowess with VTEC technology in the B16A, but this was going to be something entirely different. This wasn't about making an efficient four-cylinder engine. This was about creating a work of art that happened to combust fuel and air. The benchmark was clear: Ferrari's 348 with its 3.4-liter V8 producing around 300 horsepower. But Honda's engineers weren't content just matching Ferrari. They wanted to exceed them in every measurable way, especially in the one area where Italian exotics traditionally struggled: reliability.
In 1990, Honda unveiled the NSX to the world, and with it came the C30A, a 3.0-liter, 90-degree V6 that would redefine what a naturally aspirated engine could achieve. But calling it just another V6 would be like calling the Mona Lisa just another painting. The C30A produced 270 horsepower at 7,300 RPM and 210 pounds-feet of torque at 6,500 RPM, with a 10.2-to-1 compression ratio. Those numbers might not sound earth-shattering today, but in 1990, they represented a quantum leap in naturally aspirated power density. We're talking about 90 horsepower per liter, a figure that was practically unheard of outside of Formula One. But the real magic was in how they achieved these numbers. The C30A featured innovative titanium connecting rods, making it the first mass-production engine to use this exotic material. These titanium rods lowered reciprocating weight while increasing overall strength, allowing the engine to rev to 8,000 RPM, 700 RPM higher than would have been possible with steel rods. Think about that for a moment. In 1990, while other manufacturers were still using cast iron connecting rods in many of their engines, Honda was hand-installing titanium components that cost more than most people's entire cars. Each C30A engine was literally hand-built by master technicians at Honda's Takanazawa plant in Tochigi, Japan, with the same attention to detail you'd expect from a Swiss watchmaker. Of course, no Honda performance engine would be complete without VTEC, and the C30A was the second engine to use the VTEC system after the B16A. But this wasn't the same VTEC you'd find in a Civic. This was VTEC refined and perfected for exotic car duty. The system allowed the engine to be docile and fuel-efficient during normal driving, but when you pushed it past the 5,800 RPM engagement point, it transformed into something altogether different. The engineering that went into the C30A was obsessive to the point of being almost absurd. The cylinder block was cast from a special aluminum alloy and then given a unique bore coating process. The heads featured dual overhead camshafts with titanium retainers and lightweight valves. Even the intake manifold was a work of art, a beautifully sculpted piece that looked more like modern sculpture than automotive hardware. But perhaps the most impressive aspect of the C30A was its bore and stroke dimensions, 90 mm bore by 78 mm stroke, making it highly oversquare. This configuration was specifically chosen to allow the engine to rev freely while maintaining excellent breathing characteristics. It's the same philosophy you'd find in a motorcycle engine or a Formula One power plant. Rev high, breathe deep, and never give up. The result was an engine that could propel the NSX from 0 to 60 miles per hour in 5.7 seconds and onto a top speed of 162 miles per hour. But more importantly, it could do it day after day, year after year, without the temperamental behavior that plagued its Italian competitors. While Ferrari owners were scheduling regular maintenance appointments and keeping mechanics on speed dial, NSX owners were just adding gas and oil and enjoying the ride. Honda had achieved something that seemed impossible. They had created an exotic car engine with Honda reliability. The C30A proved that you didn't need to sacrifice dependability for performance, and it set a new standard that the automotive world is still trying to match.
By the mid-1990s, the NSX had established itself as a legitimate supercar, but Honda's engineers weren't content to rest on their laurels. The automotive landscape was evolving rapidly, with competitors pushing power figures ever higher. Ferrari had introduced the F355 with 375 horsepower, and even Porsche was extracting more power from their flat-six engines. Honda's response came in 1997 with the introduction of the C32B engine, and it represented a masterclass in evolutionary engineering. The C32B displaced 3.2 liters and featured 1 millimeter larger valves, along with an advanced sleeve manufacturing process called fiber-reinforced metal to accommodate the larger 92 millimeter bore required for the bigger pistons. The transition from C30A to C32B wasn't just about adding displacement. It was about refining an already exceptional design to extract even more performance. The bore was increased from 90 millimeters to 92 millimeters, while the stroke remained at 78 millimeters, maintaining the oversquare design philosophy that made the C30A so special. This seemingly small change in displacement, just 200 cc's, yielded significant improvements in both power and torque. The C32B produced 290 horsepower at 7,100 RPM and 224 pound-feet of torque at 5,500 RPM. This power increase dropped the 0 to 62 mile per hour time from 5.5 to 5.3 seconds and raised the top speed from 168 miles per hour to 175 miles per hour. But the numbers only tell part of the story. The C32B delivered its power in a more usable way, with a broader torque curve that made the NSX more pleasant to drive in everyday situations. The engineering improvements went far beyond just boring out the cylinders. Honda's metallurgists had developed new alloys and manufacturing processes that allowed them to create stronger, lighter components. The fiber-reinforced metal process, in particular, was revolutionary. It involved embedding metal fibers in the aluminum cylinder walls, creating a surface that was incredibly durable while still allowing for the tight tolerances needed for high-performance operation. The VTEC system was also refined for the C32B. While the basic operation remained the same, the cam profiles were optimized for the increased displacement. The transition point was moved slightly higher in the rev range, and the high cam profile was designed to take advantage of the engine's improved breathing capabilities. One of the most impressive aspects of the C32B was how Honda managed to increase performance while actually improving refinement. The larger displacement meant the engine didn't have to work as hard to produce the same amount of power, resulting in smoother operation and better fuel economy when driven gently. It was the best of both worlds: more performance when you wanted it, better manners when you didn't.
The C32B also introduced several reliability improvements based on Honda's experience with the C30A. Certain internal components were strengthened, oil passages were optimized, and the cooling system was refined. These changes weren't necessary. The C30A had already proven to be incredibly reliable, but Honda's engineers were perfectionists who were always looking for ways to improve.
More than 3 decades after the C30A first fired up and nearly 2 decades since the last C32B rolled off the production line, Honda's NSX engines continue to influence automotive engineering in ways both obvious and subtle. Their legacy extends far beyond just the NSX program. These engines helped establish Honda as a legitimate player in the high-performance arena and demonstrated that reliability and exotic performance weren't mutually exclusive concepts. The most obvious influence of the C30A and C32B can be seen in Honda's continued commitment to naturally aspirated, high-revving engines. While much of the automotive world has embraced turbocharging and electrification, Honda has continued to develop engines that prioritize rev-happy character and immediate throttle response. The K20C1 engine in the current Civic Type R, the naturally aspirated V6 in the Pilot, and even the hybrid powertrains in Honda's current lineup all trace their philosophical roots back to the NSX engines. But the influence extends beyond just Honda. The success of the NSX forced other manufacturers to reconsider their approach to exotic car engineering. The idea that a supercar could be reliable enough for daily use, a concept that the NSX proved beyond any doubt, became the new standard. Today's supercars from Ferrari, Lamborghini, and McLaren are exponentially more reliable than their predecessors from the 1990s, and much of that improvement can be traced back to the benchmark that Honda established with the NSX. The hand-built manufacturing approach pioneered by Honda for the NSX engines has also been widely adopted. Today, virtually every high-end performance engine is assembled by hand using similar precision manufacturing techniques. The idea that exotic engines deserve exotic treatment in their construction, something that Honda proved with the C30A and C32B, is now industry standard. Perhaps most importantly, the C30A and C32B engines demonstrated that engineering excellence doesn't require compromise. They proved that you could have an engine that revved to 8,000 RPM and still started every morning without drama. They showed that titanium connecting rods and hand-built precision could coexist with Honda reliability. They established that naturally aspirated engines could deliver the kind of immediate, linear power delivery that makes driving a truly transcendent experience. In today's world of turbocharged everything and increasing electrification, the NSX engines serve as a reminder of what's being lost. There's something pure and honest about a naturally aspirated engine that builds power progressively as the revs climb, something visceral about the sound of a perfectly balanced V6 screaming toward its 8,000 RPM redline. The C30A and C32B engines captured that purity and delivered it in a package that was as dependable as a Civic and as exotic as a Ferrari. For enthusiasts lucky enough to own an NSX, the engine remains the crown jewel of the experience. These engines age gracefully, maintaining their performance and character even after hundreds of thousands of miles. With proper maintenance, which, being Honda's, isn't particularly demanding, a C30A or C32B will deliver the same thrilling experience today that it did when it first left the factory in Tochigi. The market has certainly recognized the significance of these engines. NSX values have been climbing steadily, driven in part by enthusiasts who understand that the combination of performance, reliability, and hand-built craftsmanship represented by the C30A and C32B may never be repeated. In an automotive world increasingly dominated by computer-controlled turbo engines and electric motors, the NSX engines serve as a reminder of what's being lost.
Honda's C30A and C32B engines proved that you don't need to choose between exotic performance and reliable operation. They demonstrated that naturally aspirated engines could deliver power density figures that rivaled anything from Europe, while maintaining the dependability that Japanese engineering was famous for. These engines were more than just mechanical assemblies. They were statements of intent. Honda was declaring that they belonged in the same conversation as Ferrari, Porsche, and Lamborghini. And they backed up that declaration with titanium connecting rods, hand-built precision, and engineering excellence that still influences automotive development today. In a world where turbocharged complexity has become the norm, the C30A and C32B remind us of the pure joy that comes from a perfectly engineered, naturally aspirated engine. They prove that the best engineering solutions are often the simplest ones, executed with obsessive attention to detail and an unwillingness to compromise. The next time you hear an NSX screaming past at 8,000 RPM, remember that you're experiencing automotive history in motion, the sound of Honda proving that reliability and exotic performance can coexist in perfect harmony. That's the lasting legacy of Honda's greatest engines, and it's a lesson that the automotive world is still learning from today.